Hi, everyone, and welcome to this session, Clinical Decision Support with Decision Model and Notation. My name is Matteo. I'm a software engineer at Red Hat, and I'm really glad to have this opportunity today to introduce this talk for Vipul Kashyap from Northwell Health. So I will keep my introduction short because I really want for Vipul to have as much stage as possible. I would like to set the context for this presentation, starting with the following consideration. So we are seeing how cloud-based architecture together with container and microservice technologies are really a strong foundation to quickly respond and adapt business application to all required changes and evolution. However, while these are no doubt foundational elements in the digital transformation strategy, one key aspect is the ability to quickly design, develop, deploy, expose business logic and business processes. There are a few standards that can effectively help with addressing with this key aspect. One of these standards is DMN, which allow end users to define and automate business processes. And another standard is DMN, a relatively new standard in the decision management space, which allow users to define and automate business logic and business rules. DMN is a graphical-based standard. So this means that business analysts and domain experts can use a friendly visual language and visual notation to define their decision logic. What is also great about DMN is that it clearly specifies the execution semantics of the model. So this means that a DMN model authored with any tool you'd like can be shared across DMN execution engines with the interoperability now guaranteed by the standard specification itself. We at Red Hat, we provide a DMN execution engine which supports 100% of the standard at conformance level 3, that is the maximum possible, and we are committed to the support of the DMN standard. So this means for you that you can edit a DMN model with any authoring tool you'd like, and as long as this DMN model is respecting the standard, then you can expect it will execute just fine on the Red Hat Decision Manager. You will have the opportunity to witness the standard in action today with the models authored on the excellent modeling tools developed by TriZetech and running on the Red Hat platform. Personally, I'm really happy to see what the power of open source and the DMN standard are enabling, an effective collaboration between partners like Red Hat and TriZetech, and most importantly with our customer like Northwell here today. Before leaving the stage to Vipul, I'm just going to make a very brief introduction to DMN. It's not going to be exhaustive, it's going to be just a general introduction, and I will show you. So we've seen how we talked about how DMN is a visual notation, a visual-based standard, and here are some of the visual constructs that you can use with DMN. One very important thing is the decision requirement graph, is the graph that you see pictured on the slides, and it enables you with the visual notation to define how you decompose your decision logic. In this case, we're having some input of my model. These represent the input data that you want to supply for the execution, and these are the box with the round corners. Then you have some square boxes like application risk, eligibility, and routing, and these represent your decisions, your main decisions and your sub-decisions. The edges between all these boxes represents information requirements. So basically it represents what you need to know in order to complete a decision. So for instance, application risk needs to know about the applicant data in order to perform this decision. There are also other elements that you see with the cut corners boxes. These represent a reusable element. They are called business knowledge model node. And also behind all of these, what you have is that each of the decision is represented with, again, a visual standard. You have the most common decision tables. So I will show a few examples of this type of decision logic behind the DMN decision that you can model. Starting from the left, we have the decision tables. The DMN defines its own way of representing decision tables, but is usually almost standardized in what is common across the decision management practice. So you have requirements that you may match, constraints that you may match on the leftmost column, and the actual result on the most rightmost column. You have also other like simplified list of collection information. These are mainly what you would get similarly to a a table from a database or a relational database. And as well, there are a few more sophisticated or elaborated way to define like functions. For instance, this one is a boxed one to represent how you can model a piece of reusable information, a reusable function. So here you see that we have a few parameters that are provided on the topmost row. And then you would have the decision logic really exposed with the different sort of visual construct. So this is a very, crash course on DMN. There are other resources that I invite you to check out. You're going to find it in the references to get to know more about DMN. What I believe is going to be really interesting is to see from the presentation of Vipul how DMN can help with their use cases. And with that said, I'll leave the stage to Vipul. Thank you.
Thank you, Matteo. Now I will present to you how we use DMN within Northwell Health and what are the goals we set for ourselves, what we achieved, and what are some of the challenges, and of course, future work. So I'll start off by defining what we mean by clinical decision support. In the healthcare field, clinical decision support is a very well understood thing, and I'll also define what we mean by a LACE score. Again, in the healthcare field, it's a very standardized score or metric with a predictive power. Then we'll talk about the life cycle of creating a clinical decision support logic. One of the key driving motivations for us to do this work is we wanted clinical decision support logic to be authored or created by a clinical informaticist or a business analyst, and with as little dependence on IT developers as possible. That was one of our goals. And transparency and auditing was another important part. And I will illustrate all this in the context of a demo I'm going to do. Okay. So moving forward, this is the definition of clinical decision support from Wikipedia. It basically provides information specifically filtered at an appropriate time to a physician at the point of care to help him make decisions about the health care for a patient. So the way we position this is it provides the right knowledge at the right time, at the right point of care, to the right person, for the right patient, so that it's a bunch of rights so that the right thing, the care provided to the patient is optimal. LACE score is basically a predictive score which predicts the risk of readmission or death within 30 days of discharge. Using this score, a care coordinator can make decisions about the care plan and outreach for a discharged patient. So we went about and we say, hey, how do we implement LACE score within DMN? And I will share, in the next slide, I will share with you the process or the life cycle of creation of the decision of the LACE score. So we start off with basically CDS logic requirements. One of the things we tried to do is, one of the things we observed is that if you do the DMN modeling correctly, it can also help you in the requirements phase, where the DMN model itself becomes a requirements document. There are already examples of folks with some health insurers who, when they go and develop decision support logic for their claim adjudication systems, instead of taking policy manuals to the developers, they actually take DMN diagrams to their developers. So that's a very interesting use case I've heard about. So it all starts with reuse. Suppose your organization has already built 40 or 50 models. The first obvious point of reuse is the variables as input to that DMN model should be standardized. Otherwise, you won't be able to do things efficiently. The second thing is we should be able to reuse pre-existing decisions and decision services. In healthcare, content is a big deal. So, we all know that when you go to a physician's office, the physician puts some diagnosis codes like ICD-10 and so on and so forth. So in healthcare, what we do is we pre-curate collections of concepts. So we will have a set of ICD-10 codes for diabetes, another set of ICD-10 codes for heart attack, and so on and so forth. So this becomes knowledge which can be reused from model to model to model. Once created, it need not be redone. And finally, how we can reuse is using parameterized functions. I'll show you examples of each of these, right? Then we go to the point of, okay, leveraging all we have before, we will probably create new artifacts to author a DMN model. Then we refine and test a DMN model. Once the refine and test phase is over and the author is confident, we will publish it in the Red Hat execution engine. Even there, we are able to, because of the DMN standard, we are able to, for a particular patient, we are able to see the audit or trace of what decisions were activated at that point in time. And then overall, we will evaluate the model for false positives and negatives. And depending on whether it starts misbehaving, we will come back to the authoring lifecycle and update it. So this is our life cycle, which we will planning to support. So as I said, making it clinical informaticists and business analysts friendly is the key driving force behind this. It is important to get it operationally deployed so it helps the physician at the point of care. But if you get into a quick to market extensible approach of creating these models, that will make healthcare more agile and repetitive. So any of you not from healthcare? Okay, so I just want to quickly explain what a clinical informaticist is. A clinical informaticist is typically a physician who's very IT savvy. And by IT savvy, it doesn't mean that the physician knows about Kubernetes and Java and so on. It's just that he's data savvy. He can write a SQL query quickly to get the list of patients he's interested in. He's likely to understand business rules. He understands logical formulations of describing patients and so on and so forth. On the IT side, he's basically probably a senior level or a very experienced architect who has deep exposure into healthcare. So it these two kind of personas kind of fuse into a clinical informaticist. So one of the key criteria we wanted to focus on is ease of understanding by subject matter experts. So I refer to the example where some folks in a health insurance company are taking DMN models when they go and have conversations with developers instead of taking complex policy manuals for claim adjudication. This is a fantastic example. Refining and testing. So when you first do a decision support rule or logic, you never get it right the first time. You need to really test it with hundreds of use cases. This can now be done by a clinical informaticist. We don't have to throw it over the wall and then have hundreds of QA people writing detailed test cases and all that. This can be done by a BA. And he can, as he's refining and testing the model, he can store his test cases. And what are the facilities for reuse? You can reuse decisions, business knowledge models, and decision services, which I will demonstrate in the later half of the talk. And finally, the most important thing, transparency and audit and analysis of clinical decisions and recommendations. We have this huge buzz about AI and machine learning. The single biggest failing of AI today is that it is not able to explain itself, right? So this is what the problem I think DMN can solve, and I'll explain how it can do that towards the end of the talk, right? So I'm going to start the demo now, but before I go forward, I will just, if anyone has some quick questions, and then I'll jump into the demo. Okay, no questions? Good. Obviously, we'll have time at the end of the thing. All right, so let's start with the demo. So we are trying to create decision support logic for LACE rules. Now let me share with you what we have done in the past. In the past, we used rules to create LACE code. These are, as you can see, these are a bunch of rules we wrote. And as you can see, these are very detailed specifications. These specifications more around a Java programmer trying to understand what is the input, what is the output, what is the logic of the if side and the then side. The other problem with, not a problem, the other thing with rules is all these rules are kind of spread out, and the interconnections of the rules is not immediately obvious, right? For someone who doesn't understand Java coding or DRLs, rules, it's very difficult for him to get, I mean, someone like a subject matter expert who's never done Java coding in his life, who's never done SQL coding in his life, he doesn't get what's going on. Yes, there are a bunch of decision tables, but sometimes when the decision tables are too big, you have to download them from somewhere and view them. In contrast, let's look at the LACE model for DMN model for LACE. Right? Let me. Okay. So this is something. Sorry about that. Yeah, I'm trying to get the whole thing on one. This one? Okay. No, this is not. It's okay. Yeah, now it works. Thank you. So, so let's look at this model for a minute, right? This is something, if I put it in front of a subject matter expert, it's a visual representation. It captures the complete logic of the LACE code in one place. And a subject matter expert who's not a Java coder, who's not a SQL programmer, can easily understand that. What this model tells me is, in order to compute the LACE score, I need to figure out the 4 components of the LACE score, right? The acuity, the length of stay score, the emergency score, and the comorbidity score, and I need to sum them up. So I can see the progression of the sub-decisions. Now I know for computing the LACE score, I need to figure out the current encounter. I'm just going down the hierarchy a little bit. Is there a pointer? Okay, I'm just going to point here. Oh yeah, I can use mouse. Okay, I was going to point here. Okay, so he can go down to current encounter. Now he knows that in order to get the current encounter, he can go to the list of encounters, and from the list of encounters, he can check which encounter has the current encounter number, and he pulls that up. So that gives him the current encounter number. Same thing with the E score. He can say, hey, from the list of encounters, I can figure out, I can count the number of encounters which are of type emergency, right? From the list of encounters, I can check if the current transfer was from a transfer from emergency department, right? And stuff like that. For a C score, I can compute the Charlson comorbidity score and so on. So contrast what you saw between the DRL, which is very understandable to someone who's very IT savvy, to a subject matter expert. He can at least get the logic of what's going on. And this is powerful. From a requirement specification point, this is powerful. This helps the communication between the business analyst and the IT developer in a big way. Just so that you know, it has the following inputs. The diagnoses are inputs, encounters, the list of encounters, and the current encounter number are inputs. This is a business knowledge model, and I will come to that in more detail. And this is a very interesting decision node which has no input. It is basically content. And this is a very important, I think this is a very important thing for healthcare, where a lot of, it has those curation of pre-curated concepts, right? So let me go back and now, and the next step is let me refine and test. Let me show you how a business analyst or a clinical informaticist would refine and test the DMN model. So let me go back here and start the decision animator. Now as you can see, I will be iteratively testing this model, and they are waiting for input now. Unless I give the input, the model will not be tested. So now it is waiting for input to determine the current encounter, which is why this circle is here. I'm going to click on the current encounter, and I'm going to give this particular I'm going to run this. It takes a little bit of time because the network is slow. So what this will do now, it will compute the decision corresponding to the current encounter, which it will go and look at all the encounters and figure out which one of those has the current encounter number as their encounter number, which one of those has 1006, whatever the number is, 1006927222. So as you can see, it picked up the correct encounter. Right now, once we have computed that, the next thing it will do is it will. I wanted to compute the L score. So remember, the L score is based on the length. It's called based on the length of stay, and I'm going to run this, and it's going to take a little bit of time. As we go along this, I'll show you how one can deploy this into the Red Hat execution server, and I will execute the same example there and show you the results and discuss about auditability there. So the L score is 5, and this is what I mean by transparency, right? If I click on this here, it will tell me which row in the decision table prompted it to give the L score 5. So this is, even while testing and debugging, a business analyst or a clinical informaticist knows what's going on, why the result is being returned in a particular way, right? So let's move on to the next step of the, so I'm going to jump now. I'm going to go to reuse. Now this is very interesting. Let me talk about this a little bit. So if you are an organization, it's really important for you to standardize on your decision variables. That's the only way you can scale your decision authoring team. And the smartest way to do it is to leverage your enterprise data model. And if you don't have one, iteratively build one. That is my recommendation. So one of the things you do is, before you start any kind of authoring, you need to import your enterprise data model. I'm going to show you, this is an empty model. I have not done anything so far. And I'm going to go to the data type, and I'm going to import. You can import an XSD file. I believe other formats are supported too. I'm not sure if you allow imports of database schemas, but that is something we can take offline. I'm going to import this is a schema in XML, and I'm going to open it up, and I'm going to. Now these are things which have no direct mapping, so they are not imported. But these are, you can see, all these types are imported. And when I create the model, I can leverage these data types to build the model. I don't have to go create my own input data types. So imagine if you have 20 or maybe even 5 decision authors working on their own models. You want them to collaborate on a set of common data elements to build their model from. If one calls age and the other guy calls chronological age, it'll be 5 different ages floating around. It'll be a nightmare as you start deploying those models. Okay, so this is the first step in reuse, where you are able to leverage the data elements and reuse the data elements. The next step is, how can I reuse pre-existing decisions and decision services? So obviously, if I've built a bunch of decision models before, I should be able to leverage some of my pre-built decision models. And I'm going to show you how we do that. So I'm going to cross this out. Now one of the things we can do is, I can search and say, I can search on a L score, which I built, right? And I can drag and drop this. The interesting thing is, whenever you reuse a decision node, all the sub-decisions under it gets reused, because the decision node rarely stands by itself. It is a decision in the context of its sub-decisions and its data elements. So actually, I don't know why the second decision is, and then we can go back and start dragging and dropping. Remember, we are reusing the data elements. So we can go and drag and drop the inputs for these things. So we Um, right. So even though I didn't know anything about, suppose I'm building this from afresh, I can check other models who have created this and drag and drop and create a new model very quickly. Right. This is an example of reusing a decision. Another way of reusing a decision is something called as decision services. Now, we can stop this for now. So remember, we created these. We created this whole interesting model. But remember, suppose I'm not interested in. Suppose my fellow authors come and tell me, you know what? If somehow you could carve out the else code piece and give it to me, they may not be interested in other parts of the model, right? So the way we can do that is by creating a decision service where you can call this some kind of an else code service or something of that sort. And you can now this is one way of creating the else code service, but what this service now does is it expects you to provide the current encounter as an input to the service. But that may not be useful, because then that other person may actually want to reuse your logic for current encounter. So this becomes an encapsulated decision within a service, and now this service basically expects the same inputs as which you gave the original service, the current encounter and encounters. So now you can save the model and share the service, and future DMN authors can reuse that service and expand it and see what it means without having to recode the service on their part, right? So this is a powerful mechanism to reuse pieces of the logic of the model. Okay, so let's move on. This is what I showed. Now, pre-curated concepts, this is the most important piece for healthcare. Let me explain to you what it is. Let's go back to the model, and let me now remember I told you about this particular decision node ICD-10 value set, which has no input, but it is providing us the following information. Let's see what it gives us. It takes a while because it has a bunch of data associated with it. Okay, so instead of pregnant pauses of silence, let me show you what it really will bring it up. This is what will bring up. If you can look at this, this is basically a table where each column of the table specifies a disease. So the first column says ICD-10 underscore MI underscore 1. What this tells you is that this is a curated collection of concepts of ICD-10 codes for myocardial infarction, which is another way of saying heart attack, version 1. And instead of each modeler defining his own subsets in different models, you can capture all the subsets, pre-create them. In the healthcare context, this work is done by people called medical terminologists. They understand the structure of ICD-10 and SNOMED and all the other healthcare vocabularies. They're called ontologists. They understand the ontology very well. They will build this for you, and hopefully this has returned the results. So far it has. So they will build this for you, and now this becomes a decision node you can reuse in another model. Just like the way we reuse the else core node in another model, we can reuse this. Just to show you how this can be leveraged, essentially this is leveraged. In this case, this is leveraged in the context of a decision table, where if the code is a member of the ICD-10 value set ICD-10 underscore MI colon 1, then you have myocardial infarction. Right? So just to reiterate, the power here is that this could be an enterprise knowledge artifact. created by someone out there. And every decision modeler can just leverage it for building his decision logic. So this is a very powerful way of reuse. Right? So now I'm going to talk about the final reuse step, parameterized functions, also called as business knowledge models. Here is an example in the model. Suppose you want to figure out, given the current encounter for which you want to compute the lay score, what is the encounter which happened before the current encounter? Now, this is a very common piece of knowledge, right? So we model it as a function. Let's see how it looks like. This is basically a simple function. It takes two inputs. What is the input encounter, and what is the list of encounters based on which I want to get the input encounter, the previous encounter. So this is a very generic function. All you want to know is, given an encounter, which is the previous encounter to this encounter, right? And the logic is very simple. If you can understand some field, basically every encounter has an element called prior visit number, and if the encounter number matches the prior visit number, then it was the prior encounter for that encounter. It's a simple thing stored in the data model. So this can apply to your current encounter, to any future encounter, to a past encounter. It doesn't matter, but this is something which can be, again, created by the informaticist or business analyst and stored in a knowledge artifact repository. And just like we reused the decision node here, wish we had smart tools which can understand the resolution of a screen and automatically fit themselves, but that's another thing for another day. But so just like we can reuse the ICD-10 value set, we can reuse this function, and this is the way we would invoke this function. Basically, you call prior encounter with instantiated parameters, which is your current encounters list and a current encounter. Okay, so this is just a regular function calling applied to decision modeling. So think of it as a parameterized decision, and you can plug in parameters. Okay. So what have I stepped through so far? So yeah, so the final thing I want to show is deploy the model and operational auditing. So we deployed the model using the Red Hat platform, and I'm going to show you the payload which is input to it. So okay, I need to. So interesting. I'm not able to scroll, but okay, yeah, I'm able to. So here's the payload. So this is the model. This is the URL, URI or whatever. This is the name of the model. These are the input parameters. So remember we had a list of 3 encounters. These are the encounters in the payload. The same thing which I showed in the decision animator. Now these are in a JSON file. And remember we gave the current encounter number, so this is how we specify it. Let me go back and refresh your memory. This is exactly what we did here. Let's go back. Oh, I lost this here somehow. Anyway, but if you remember from the previous case, this is exactly what we did here. And I'm going to click send, and I got a success. Now it is very important, if you remember, the inputs first computed current encounter, and then from the current encounter we took the length of stay and we put it in a decision table, and then that gave us the final L score. So let's see how we can trace it here. So this is the decision trace at runtime. This is at runtime. So imagine a situation where you have a claim adjudication scenario where a member calls you and says, why was my claim denied? You can quickly invoke the DMN model for that member, and it will give you the decision trace. And in this particular case, may I show you the decision trace, where these are all the inputs. Now the first thing is it computes the current encounter. It shows you the value of the current encounter, right? And then it shows you all the values of, in this case, the L score is what we were interested in. These are the decision results. So it will start computing the decision. So it says the first decision name it computes is the current encounter decision, right? Let me go back to, remember if you give the encounters and the current encounter as input, the first decision it computes is the current encounter, correct? So this is what it is doing here. This is, and it is showing you that this is the encounter. Remember, this is with the encounter number and the length of stay in days. The second thing it does, it computes the L score, which I E score, A score, number of ED. This is the L score, and the result is 5. Remember, in this case, if you remember, the current encounter now feeds into the L score decision node. So having convinced you that the same thing is happening on the execution server, which happened in the decision animator, let's take a step back, and this is a very powerful functionality. I have to reiterate that current AI models do not have support for this. You can give data to a current AI model, it will come back and tell you, give you a particular recommendation, or it will give you a particular prediction, but it will not be able to tell you in business terms why it gave you that recommendation. Now, there are pros and cons, we can have a debate, but I think this is one of the powerful value of a DMN model. So I'll move on. So now we are close to heading. So what we are doing, we are very close to operationally deploying the DMN model for lay score in operations. This will drive, as I said, care coordinators to figure out whether to reach out and talk to him and stuff like that. The next one we're going to work on is acute kidney injury. This is pure clinical decision support. That is more in the clinical care delivery context, where a physician will look at acute kidney injury and decide what staging and decide what to do with them. The next step we do is we need to train clinical informaticists and business analysts to write DMN models. It requires a special top-down thinking, because typically IT developers tend to have bottom-up thinking. They kind of write query after query and Java logic, but this requires top-down thinking. The next, these are two futuristic projects we want to look at. We want to look at DMN as an abstraction layer. So one thing to realize is that DMN is about decisions. It's not about rules. That's point number one. What does that mean is you can capture logic in decisions, and that logic may be implemented as a set of business rules, a set of predictive modeling markup, like predictive modeling language models, or as SQL queries. Now, the SQL queries is very, very important here. The fact of the matter is that a lot more people know about SQL queries than they know about business rules. It's a far more prevalent method of logic specification. So a clinical informaticist is more likely to have known SQL queries than business rules. So having DMN models as a layer on top of SQL queries and providing the explanation and the ease of understanding over SQL queries would be a great thing. So this is one of our ideas which we want to collaborate with Red Hat and anyone else. And the final thing is event-based DMN. Currently, DMN has a stateless architecture. But what we want is that as new events come in, we can encapsulate portions of the DMN as a collection of services. And based on the event type, the appropriate service could be computed, and the state of the patient can be updated in memory. So again, we are working on this. Just like let me show you. Just like we encapsulated the L service, we can encapsulate the A service, E service, and C service, right? And then whenever a new event type comes in, the appropriate service is called, and the patient state gets updated and stored persisted in memory somewhere, right? So this is where we are. Thank you for your time. And yes, some acknowledgements. Vish Anantharaman is my boss. He's the one who encouraged me to go after DMN models. Hari, Krishna, Nandigam, and Amitabh work for me. Hari helps in the informatics. He's an informaticist, and Amitabh is an architect, technical person who's helping me out with the APIs and all that. And we just published a special report on DMN. I would encourage you to go out and see how we are using DMN as a part of the, using the Red Hat Decision Manager to implement clinical decision support in our organization. And of course, as usual, feel free to reach out to me and if you have any questions and so on and so forth. So thank you for your time and look forward to any questions if you have any.